Hello, myself Dr. Anita Chaudhary. In today's session, we will discuss about the number systems and its conversion in computer. Okay, so uh, what we have already discussed about the number system. Like number systems, we use basically binary number system. Okay, and decimal number system, the range of binary is 0, 1, range of decimal is 0 to 9, and octal number system where the ranges start from 0 to 7, and hexadecimal 0 to F, uh, where F represents the 15. Okay, decimal number 15. Now, in this session, we discuss about the conversions among these bases. Now, what is the basis? Basis means decimal base is 10, binary base is 2, octal base is 8, and hexadecimal base is 16. So, how we convert, basically, how we convert one base into the number into the another base, where assume here the base, the number here is the base 2, and we want to convert it into the decimal number system where base is 10. So from one base to another base. Now this is the pictorial diagram how we can convert them. Like if we want to convert decimal into the binary, then what we have to do, we have to divide the number by 2, and if we convert the binary into the decimal, then we multiply each bit by 2 to the power n, where n is basically the weight of the bit. Okay, and the weights are start from the right side. Okay, like 0 1 1 0 1. If this is the number, then the weight of this number, it start from the right side, and the rightmost bit weight is 0, and then it is incremented from right to left, 0 1 2, and so on. Okay, now, same, if we want to convert the binary number into the hexadecimal, then what we have to do? We just group the bits into the 4-bit combination from the right to left. And if we want to convert hexadecimal to the binary, then what we have to do? We have to just take a 4-bit equivalent binary representation. Same way, if we want to convert binary to octal, then we just group it into the 3 and start it from the right side. Whereas if octal to binary, then we take the 3-bit equivalent binary representation of the bit. So, and decimal to octal, we just divide the number by 8 to got the octal number from the decimal. And if we want to convert octal to decimal, then multiply each bit by 8 to the power n. Same, n is the weightage of the number. Now, octal to hexadecimal, uh, uh, in for hexadecimal, we just take a 4-bit equivalent binary representation for the hexadecimal, and from the hexa to octa, we just take 3-bit equivalent binary representation. Okay, now this is the quick example. Like this is the value and this is the base. Now what we have to do, if we want to convert base 10 into the base 2, then the base 2 is represent the binary representation, means the range is 0 or 1. Okay, so what we have to do, we have to divide this 25 by 2, because the base is 2. So after division we got this number like 2 1 2, the remainder is 1, again divided by 2 we got 6 0 2. Okay, now here 3, remainder again 0 2, Now, uh, 1 remainder is what? Remainder is 1, 2, again divided, remainder 0, 1. Okay. Now, how we represent this one in this uh, bottom to top? So, bottom number is 1, 1, 0, 0, 1. So, this is the binary equivalent of the number 25. Okay, if we want to convert it into the base 8, then take the octal. In a octal representation, the number of bits is representation is 3 bit. Okay, so what we have to do, we have to take 3 bits. Now this 3 bit combination 001, it represent 1, and 11 0, we assume it here 0. So 1 1 represent what? 3. So the number in octal representation is 31. Now if we want the hexadecimal, so just take binary to hexa. Now in a hexadecimal representation, the bit is representing using the 4-bit representation. So take 4 bit from the right to the left. Now 4-bit, which is 1001. Now 1001 is represent what? 9. And now next is the 10, and we assume here 00. Now 0001 is represent what? 1. So the number is 19. Now this is the hexadecimal representation. Okay. So now we start one by one decimal to decimal conversion. So if the base is same, then the number remains the same. Okay, because the base is 10, the weightage start from 0, 1, 2, and if we convert it, then we got the same number because the base is same. Now here, what is the least significant bit and most significant bit? Now, if the number is 1001 0, then what is the least significant bit and what is the most significant bit? This number is called most significant bit and this number is called least significant bit. Why? Because the weightage of this bit is very low, that's why this is called least significant bit, and the weightage of this bit is very high because the weightage of the bit is start from right side to the left side, and so the weightage of this leftmost bit is very high, so that's why that is called the most significant bit. Now if we represent the number in a dot also, so the weightage is start from this. Now this is the powers. So we can see that the powers is incrementing, uh, and in a integer part, whereas in the fractional part the powers will be decremented by 1, and the power is start from -1 and so on. Whereas in the integer part, the power is start from 0. Here you can say r to the power 0, which means 1. So we there is no need to represent r to the power 0. We directly pick the number itself. Okay. So in an integer part, the power is start from 0 to +1 direction. Okay. Now here we take an example for binary to decimal representation. Now, if we want to convert binary to decimal, then what we have to do, we just multiply each bit by 2 to the power n, where n is the weightage. Now, take this one as an example. This is the binary representation. What we have to do, we have to convert it into the base 10. Now, uh, this is the number, take the powers 0, 1, 2, 3, 4 and 5. Okay. So start from 0 to leftmost side. Now this is the power 5. So what we have to do, we just take the base value and multiply it with the value itself. So 1 is multiplied by 2 to the power 0. Now next 1 is multiplied by what? 2 to the power 1. Next bit is 0, 0 is multiplied by 2 to the power 2. Next 1 is multiplied by 2 to the power 3. Next to 0, 0 is multiplied by 2 to the power 4, and 1 is multiplied by 2 to the power 5. So the power is always what? In an increment way. Okay, now what we have to do, we just add all these numbers and we got 43 base 10. So the binary conversion of 101011 is 43 base 10. Now octal to decimal. In an octal to decimal, what we have to do, we just multiply each bit by 8 to the power n. And now this one, uh, uh, so here the base is 8 and we want the decimal representation. Now do the same thing. We have assigned first the weightage to each of the value and each of the digit. So the value 4 having the weightage 0. So what we have to do, we just multiply 4 by 8 to the power 0. 8 is here and the power is here. Okay, and the value is here. Okay, so 4 multiplied 8 base and power, which is weightage. Now 2 multiplied by 8 to the power 1 and 7 multiplied by 8 to the power 2. Now to got the value, what we have to do, we have to add all these values. Okay, now hexadecimal to decimal conversion. Now hexadecimal means multiply each bit by 16 to the power n. Okay, same if the value is ABC. Now in a case of hexadecimal representations, the range of hexadecimal is 0 to 9 and A to F. Okay, where this is the same integer number 0 to 9, where A is represent 10 and F is represent what? 15. Now we have to replace first value of A, B, C. A represents 10, B represent 11 and C represent 12. Now the weightage of these numbers are 0, 1, 2. Okay, now what we have to do, we just take the base and we have to multiply the value, sorry, base with powers. It's a powers. So C is multiplied by with 16 to the power 0 and the value of C is 12 and the base is 16 and the what is the power? Power is 0. Okay, so now we replace C with 12. 12 multiplied by 16 to the power 0 means 1. Okay. Now B is what? 11. So 11 multiplied by 16. Same A is what? A is 10. 10 multiplied by 16 to the power what? 2. Okay. So by adding all these values, we got the result. Okay. Now next is the decimal to binary representation. In case of decimal to binary, we have to divide the number by 2 and take the uh, read it from bottom to top as we have already discussed. So if we want to convert 125 base 10 to base 2, now we have to divide it. Okay, so after step by step division, what we have to do, just 12, 1 to 5, when we divide it by 2, we got 6 2 and the remainder is 1. Now how we read these values? Okay, last remainder is 0 and now that is not divisible by 0. So now we start reading the values from top to better bottom, and that is sorry, bottom to top, and that is the answer. So the answer is the 111 1101, and its base is what? 2. This is the base. So this is the final answer. Now, octal to binary, how we convert it? Convert each octal digit to a 3-bit equivalent binary representation first. So 705. This is the what? Octal representation. Now, we just convert it using the 3-bit pairing. So first we take the 3-bit combination of 5, which is 101, 3-bit combination of 0, which is 000, and 3-bit combination of 7, which is 111, and that is the final answer. So easy. Hexadecimal to binary. Now take 4-bit equivalent binary representation. Now this is the number. What we have to do? We have to just take representation of f in a 4-bit. Okay. So 4-bit representation of f is this one, 4-bit representation of a, this one, 0, this one, and 1 is this one. And this is the final answer. So thank you. If you have any query, just ping a message in my video.